Okay, ladies and gentlemen, good morning. Welcome to this seventh Military Metrology for Aerospace. I would like to thank all people attending and listening to us. I see that there is a very big audience. Let's start with the first greetings and welcome from the organizing committee. Pasquale, that's your floor is yours.
Thank you, Dario. And thank you for organizing again the session of military metrology for aerospace. This year we had the pleasure to share this event not only with the AFCEA Chapter of Naples, but also with the Association of Engineers Naples. And a special thanks to the President, Professor Eduardo Cosenza, and a warm hug in this moment for his life. The edition is very rich of very important speakers from military and industrial academical world. It is interesting to note that this year we had also, as usual, the patronage of Italian Air Force, supporting together Italian Navy. So we have also this official presentation. The military metrology for aerospace is a part of a great event that virtually, unfortunately, is held in Naples, at the University of Naples Federico II. We hope that our friend in Naples will invite again to be on site, and not only virtually. This event collected about more than 150 papers this year from 27 countries, if I remember. Yesterday, we had a very interesting roundtable on education in metrology for aerospace and a tutorial on a new field of research as a lot of drones swarm, a lot of drones were working and flying together. As usual, this conference will offer 3 invited speakers, 1 per day, awards and sponsors from companies working in the field. Thank you again, Dario, for organizing with our friend of the board of AFCEA Chapter Naples this half day that I hope next year will be in Pisa, just in front of the pending tower. Thank you for all the people and the colleagues of the Association of Engineers attending this event, and enjoy the presentation of our speakers. Thank you.
Oh, thank you, Professor Da Ponte. Thank you very much indeed, Pasquale. I say that, okay, we are now at the 7th edition. It seems to me yesterday when we started with the first edition 7 years ago in Pozzuoli at the Italian Air Force Academy. Today, the audience, thanks also to the Engineer Association of Naples, is huge. I see a lot of people connected. So this is also for me the chance to advertise and sponsor AFCEA. So I would like to spend a few words before we start with the real conference about AFCEA. Gianluca, can you see the presentation?
No.
Okay.
Yes, now we can see it.
Okay.
Could you play the presentation mode?
See, I did, but it doesn't work. It doesn't work. Okay. Unfortunately, it doesn't work. Okay, so I have to go one by one in this way. Okay, so let's start. What is AFCEA International? It's a place where industry expertise meets mainly government needs. AFCEA is an international organization. It is a non-profit organization that helps members advance information technology, communication, electronics, intelligence, command and control capabilities since 1946. The period when it was funded is just after the Second World War, during the period of the so-called Cold War. So it's an answer, technological answer from the Western world to the Eastern part. As of today, the association is structured in 140 chapters located in more than 30 countries. Those are figures from a couple of days ago. We have more than 29,500 individual members and more than 1,500 corporate members, that means companies. The presence is mostly related, as I said, to the Western world, but as you can see from the situation, from the slide, it is there are also locations which are not really NATO or Eastern Western world, like Australia, South America, and so on. What's the situation in Italy and Europe? In Italy, we have 3 chapters: Naples, Rome, and Aviano. Rome is one of the largest chapters in the world, and Naples is instead one of the historical chapters. I'm really proud of being Naples chapter president, because Naples was founded in 1961, and it is the 3rd chapter in Europe after London and Paris. Of course, most of those chapters are located in places related to the presence of international commands or international troops. And this is Naples is just was so founded so early, just because of the presence of NATO in Naples itself. I'm really, this may be also the reason why I here, because of my previous experience in NATO. Just one quick question. Why should I join AFCEA International? Well, AFCEA, as I said, is a forum where people are connected, where ideas and solutions are spread and divided, and AFCEA is a forum for military, government, academic, and industrial communities to collaborate all together to give the technology and the strategy to those who serve. I mean, it's a matter of alignment with the needs of government and defense. After why, how to join AFCEA? The easiest way is to contact our secretary at this email address, secretaria@afceanaples.it, or go directly to the website, select the membership menu, then about membership, individual benefits, join now, and then fill the individual membership application. I have to say that there is a magazine which is published, is printed every month, is Signal is the name, which is very, very, very interesting. And I suggest everybody to try at least for a while this kind of membership. So this concludes my brief for the moment. I would like to thank all the speakers and also President Cosenza for being here and for having given his positive answer to share with us this event. Please, President, the floor is yours now.
Oh, thank you very much. It's really a pleasure and an honor to give a welcome to everybody. I have to thank AFCEA in particular the Naples chapter. So the president Dario Nicolella. I have to thank the University of Sannio, so the friend of the colleague Pasquale da Ponte. The link between Naples and AFCEA, and more in general with the Air Force problems, it's a link very important, very old, because there are two reasons. The first one was mentioned also by Dario Nicolella, is there is a big NATO center in Naples or in the large area of Naples. But the second one is that the Air Force Academy is in Naples, and so all the students that studied engineering, but also not engineering, in Pozzuoli, in Air Force Academy, are students of the University of Naples Federico II. So for us, it's really a pleasure, really an honor. And so now I am a professor of the University of Naples, but now I am president of the Naples Association of Engineers. It's really interesting, this connection between the Association of Engineers and this important conference. It may appear that the theme, that the argument, the topic, it's far from the interest of common engineer. I don't think that it's correct, because from military, especially from aerospace, military engineering, start a lot of studies, a lot of projects that in few years became also project and ideas for common engineers. And I think that the time to have this connection is reducing if we think to cybersecurity or the use of drones and so on. So I think that the topics of this conference, it's interesting, very interesting also for engineers that are in the association. So I was very positive when Dario Nicolella suggested the association to connect with this event. So thank you very much for this link for this conference with the Assembly of Neapolitan Engineers. Thank you, and I'm sure that all the speaks, all the topics will be very interesting for everybody. So thank you, Dario. Thank you again.
Okay, thank you very much, Didi. You got the point with the NATO and the Air Force Academy. I mean, those are really two milestones in this event. Thank you very much indeed for participation. I know that it is another moment in your life. Thank you again. Okay, now we are a little bit ahead of the program, so I think we can start. If Stefano is ready, we can start with the first speaker. Technical speaker is Capitan Navy Stefano Reversi. He is the Chief of Policy and Innovation Office of the Italian Defense Space General Office, and he will speak about defense and space. Stefano, good morning. Thank you for coming and for participating to this event. The floor is yours.
Good morning. Thank you very much. I would like, first of all, to thank the organizing committee for this invitation to this event. For me, it's an honor and privilege to speak to you here today. As General Dario Nicolella said, I'm the Chief of the Policy Innovation Office in the Space General Office. My office is in charge of policy, tech innovation, and international cooperation. My intervention is about the space domain. in particular how the Italian defense acts in it. I have a presentation and now I try to share my desktop to show it. Can you see the presentation?
Yes, perfectly.
Okay. So the object of the briefing, as I said before, is to present the evolution of the space environment and to introduce the latest developments of the Italian defense in the space sector. This is the agenda. We'll take a quick glance of the space evolution from an opportunities risks approach. Then I'll present the overall Italian MOD organization for space with a particular focus on policy aspects and capabilities. And finally, the conclusions and some takeaway. As it is well known, space is an essential enabler for the daily life of every single person on Earth. But there is more. Space is going to represent the new game changer for the socio-economic growth, with several opportunities for a better quality of life for all humankind. This in accordance with the United Nations Sustainable Development Goals. In the near future, satellite population and activities in space will drastically increase, and the access to space will no longer be a spacefaring nation's prerogative. Moreover, the increasing presence of private actors in space is leveraging new business models, which will surely pave the way to innovative job opportunities and solutions. This process is called the new space, with reference to the recent commercialization of the space sector. However, it is important to mention that there are also several risks associated to the new space. For sure, uncontrolled business could make space more congested and competitive, with impact on its sustainability and peaceful use. Furthermore, the need for economic competition could foster the cheapness than the reliability of technology put into space, increasing the risk of collision, breakups, and orbital debris. On the other hand, the proliferation of dual-use systems has blurred the line between military and civil use, making it more difficult to protect and defend space assets and to identify threats. Furthermore, new technologies are paving the way for the new space activities, like in-orbit servicing, without an updated regulatory framework. This fact could make the whole process vulnerable and uncertain. So, the space law is an essential piece of the puzzle, even though the current legal framework seems to be outdated respect to the new technology availability and respect to the potential new space activities. The United Nations, with a recent resolution, you see in the slide, the number 7536, launched a new initiative, currently under the evaluation by nations, to reduce threats to space systems in order to maintain outer space as a peaceful, safe, stable, and sustainable environment, free from an arms race and conflict for the benefit of all. The adoption of voluntary measures and responsible behavior commitments of a non-legally binding nature could be an important intermediate step in maximizing the chances of a successful outcome of future negotiation for a binding treaty. The defense forces could help the process to make the space environment safer, increasing trust and supporting space diplomacy between nations, also improving the military-civil cooperation in the development of future space activities. Establishing a solid and credible space power can surely concur to set up an international deterrence framework by ensuring 24/7 support to space activities. So as we saw, space provides essential services to our society, like positioning and navigation, satellite communications, Earth observation, timing, and synchronization. It is important to say also that other than the risks and opportunities associated with the new space, there are also risks associated with the environment, like the space weather and the space debris, and the threats associated with the intentional behaviors like cyber jamming and anti-satellite missiles. So space, from a military point of view, has gone from being considered an enabling environment to a domain of operations. In this context, in 2019, NATO recognized space as an operational domain. In that direction, coming to the Italian mode space, the vision of the Italian Chief of Defense Staff states that a space joint component must be able to conduct operations in the space domain to the purpose of protecting national space infrastructures and ensure the proper freedom of access and maneuver in space. The space joint component will contribute to the implementation of the national space security strategy. To do that, the Italian MOD launched in 2018 a significant transformation process, which led to the establishment of two organizational elements, one at a strategic level and one at an operational level, the Space General Office and the Space Operations Command. Nowadays, both these elements depending directly from the Italian Chief of Defense Staffs. The Space General Office operates at a strategic level. Its main tasks are to define the strategy, policy, and doctrine, follow the technological innovation, and for both military and dual space programs. It's responsible for the political and military leadership advice, and last but not least, oversees international cooperation. The Space Operation Command acts at the operational level. Among its tasks, it operates to assure protection and defense of national space infrastructure, merge all space data and information to achieve the space domain awareness. It has full control and authority on space operations. It deals with the integration of space domain products into the other domains operations. And finally, it acts as a national and international operational interface. Regarding policy, we are currently working on three main documents: the Defense Space Strategy, the New Space Defense Plan, and the National Joint Doctrine on Space Operations. The Defense Space Strategy aims at defining the military national level of ambition by setting the goals for the development of the military space sector for the years to come. It addresses important topics such as doctrine development, organization adaptation, space infrastructure development, and resources assessment, both in terms of personnel and investments. This document is currently under approval. we expect that it will be approved in the next month. The next step will be the re-elaboration of the Space Defense Plan, since the previous edition dates back to 2009, in order to detail the strategies, objectives in terms of timeline, resources, and to set up relevant programs. At the same time, we are working to develop an initial doctrine document for space operations, which is expected to be available in an advanced draft by the end of this year. Moving to the operational level, the Space Operations Command, by working on achieving the space domain awareness, aims at two main goals. It manages all the space operations and ensures the full exploitation of the space capabilities, and it deals with the integration and enhancement of the space services in the other operational domains. The Space Operations Command reached its initial operational capability last May. It is involved in several lines of effort. Some of the ongoing activities are talks with the Intel department in order to set up the Space Intel function, testing our planning directives, activation of the legal advisor function, and the activation of national education and training courses in the space domain. A recent common operation performed by the Space Operations Command was the reorbiting of the geostationary telecommunication satellite SICRAL-1 to the graveyard orbit. Now, let me briefly show you our main objectives in terms of capabilities development. Regarding SATCOM, we launched the program for the third generation geostationary SATCOM satellite. And we are thinking about a low latency and high bandwidth SATCOM capability through a project for the development of a constellation of small low orbit satellites, which will ensure connections with national coverage and other areas of strategic national interest. In the field of space situational awareness, we intend to increase the defense capability by acquiring new sensors and upgrading the existing ones. In particular, the new sensors that will complement the existing ones will be a third military telescope for MEO and geo tracking, a new small radar for LEO tracking, the development of a new optical sensor for LEO, MEO, and geo surveillance, tracking, and characterization, and the development of a new SSA radar sensor for LEO surveillance, tracking, and characterization. We are also working in terms of software evolution on better data fusion. Despite our efforts for national sensors, we believe that SSA capability could only be achieved through a solid international cooperation. In this sense, we cooperate with the United States, and we are working with France to set up a collaboration. Looking ahead, we cannot help but investigate the chances of space-based SSA. In terms of Earth observation, we are progressing with both optical and radar third-generation satellites, and considering a microsatellite constellation proposal. With regard to PNT capabilities, we are defining the bilateral agreement to start testing the next generation military GPS signal called M-Code. We are supporting the activities for the development of a common user segment to access the encrypted service of the Galileo system, the public regulated service. And we are supporting at national level the development of a dual constellation GPS Galileo secure receiver. About emerging technologies related to space, the MOD main interest currently sees the technologies useful to improve the protection and the resilience of space assets, especially in congested and interfered scenarios, to achieve in-orbit logistics, to have rapid maneuver capabilities, and last but not least, to have a better information exploitation from multiple data sources. All the technology listed in the slide concur to these objectives. In conclusion, it is possible to say with no doubts that the space environment is more and more contested, congested, and competitive. But at the same time, it offers unprecedented new opportunities as well as increasing risks and threats. To face this new challenge, the Italian MOD has recently adapted its organization to operate in the space domain. In order to maintain its standards of efficiency and effectiveness, it is necessary to constantly work to improve its space capabilities. In this way, it will be possible to keep the space environment safe in order to guarantee the continuity and the resilience of strategic services for all humankind. So thank you very much indeed for your kind attention, and I give the floor to the General Nicolella. Thank you.
Okay, thank you, Stefano, for your briefing. I forgot to tell one thing to the audience. If you have questions, you can write those questions in the chat, and Engineer Mazzilli will manage those. Or if there are so many, too many, I will ask directly to the speaker, selecting just a few among those. So before you have just to give you time to write some questions, I have two questions for you, Stefano. The first one, you mentioned to the chain of command of this office. Just to be clear, does it depend on deputy chief of staff or directly to the CHOD?
No, they depend both the Space General Office and the Space Operations Command. Both depends from the CHOD. No, not from the device.
Okay.
Directly from the CHOD.
No, okay, thank you. No, because in your slide you mentioned defense stuff. Okay, so is something
yes.
that no, okay, but you know, there is an ambiguity between English, Italian and English. I know very well because I have been in NATO for several years. So this is the reason why I asked you, just to be clear about this. The second one, if you can tell us, is not a secret. AUMA is a pretty new office. Last year we discussed with General Capasso to have a briefing. I said, no, maybe it's better next year. That means this year. So it's a pretty new office. How much has been achieved so far? And when you think you reach, if not yet achieved, the final operation capability?
Talking about the Space General Office, the Space General Office was established in 2019, in November 2019, if I remember well. And there isn't a path to achieve full operational capability for the Space General Office, but we have a full staff, and I think that we already achieved our full operational capability. Okay. Talking about the Space Operational Command, the Space Operational Command was established in June 2020. As I said in the presentation before, it achieved its IOC, the initial operational capability, in May in this year. And there is a path to achieve the full operational capability, but now it's too early to say when. So it's too early.
Okay, thank you. There is a question from Marco Maffei. If you if you are able to ask directly, Marco?
Yes, you can just unmute your microphone and make your question.
Yes, hello. Thank you for your presentation. I was just wondering if you could elaborate a little bit more about the investigation on future spaceborne radars for supporting space situational awareness. Thank you.
Okay, as I said in the slide about our future programs, we are thinking now, or there is no a program, but we are thinking about space-based SSA sensors to support SSA. The program, about this program, perhaps Fernando Dolce could tell us something in its briefing, but we are thinking about a small satellite constellation with radar derived from the Cosmos SkyMed constellation. There is no more for now.
Thank you.
You're welcome.
Okay, if there are no more questions, I thank Stefano for his exhaustive briefing. Thank you very much indeed. Please extend my greetings to your boss again. And thank you for having supported us with this very interesting conference and speech. Okay, thank you, Stefano. So we go to the next one.
Thank you.
Yes, okay, with Brigadier General retired Giovanni Savoldelli Petrocchi. He will speak us about air urban mobility in Turin. Is a project, Skydate project that is working about. So Giovanni, the floor is yours. Please go ahead.
Thank you, Dario, and I want to thank you also, Professor Del Ponte, for this meeting. Let's start with a short video, if I should try. Is on the screen?
Yes, it is.
It is.
The Aeroitalia Airport in Turin bears witness to over 100 years of Italian aviation history. Since 1908, only a few years after the first flight by the Wright brothers, Turin has become a pioneer in the design and production of aircrafts. Fiat Aviazione has produced 32,000 engines and 13,000 airplanes sold to 27 countries. Today, the most important Italian aerospace industrial hub has developed next to the airport. Leonardo, Thales Alenia Space, and Altec are also based here. We too have been present for over 10 years with our subsidiary, DigiSky, a company focusing on advanced avionics systems. In 2009, its founder, Maurizio Kelly, a former NASA astronaut and test pilot, set the world speed record for an electrically powered aircraft, the Sky Spark. By 2035, more than 35,000 air taxis, drones, and unmanned vehicles will be flying worldwide, providing for a combined market worth more than
Something wrong?
No,
Can
you
you hear me?
cannot leave us. Yes, we can, but you cannot leave us with half movie. You have to complete, otherwise we don't know the end.
Yeah, I know. Let me try why download.
Yeah, I would suggest to download it locally on your computer and then share the video from your computer.
Sorry for the inconvenience. It's so slow, but it's going on.
So I suppose that you are downloading the file. In this case, you should, okay, I will stop sharing. Okay, you should share again your screen. In this case, you have to select
Again,
the entire screen and not only a single application.
Yeah. Oh, let me come back to the your screen, then wait the final download, and then I try again. Just a few seconds, and I hope to show you again the video. And I will try to start when the video.
Okay, thank you.
So I try to take again the screen. No, same before.
You are not sharing the entire screen. You are sharing just a Dropbox window.
Yeah, but where is the video? Let me try now. Is on the screen?
No, you are not sharing the screen. You are sharing the Dropbox window.
Okay, hold on.
Not the same.
No.
The Italia airport in Turin bears witness to
Let me try if on the other side. No, but I was in the Dropbox, but I'm not sure if I. No, same. I can try, I'm sorry. I can try, then I move to my presentation. You can see my presentation on the screen?
Yes, we can see it.
Okay, I'm very sorry for the video, but I will present the Skygate project. Skygate project is the first one air urban mobility Italian project in Italy. Advanced air mobility is a new form of aviation utilizing airspace above congested cities to better serve the public, business, and emergency responders. Boeing called air urban mobility the third era for the civilian air force. Social benefits will be numerous. We see this new technology providing more convenient transportation and delivery of goods. We note the importance of air urban mobility being accessible to all, initially focusing on public safety, emergency response, and air taxi transportation. Air urban mobility is a concept that proposes to develop short-range, point-to-point transportation systems in metropolitan area using vertical takeoff and landing VTOL or short takeoff on landing aircraft. Through the strong technological innovation and the green transition, it has the double objective to improve the mobility intra-city and to offer alternative opportunities in the interconnection intercity with the use of eVTOL aircraft, with the construction of a sustainable dedicated infrastructure. Initially for eVTOL development, the airport will be the focus for passenger transport in the city center and nearby municipalities, attractions. Then we'll create areas within the city for intercity travel with eVTOL operators certified by EASA agency. A study by Volocopter estimates an air urban mobility market opportunity worth 241 billion by 2035. 131 billion will originate by the passenger segment of the eVTOL market. In addition to the traffic management, regulations and certifications, the key driver for scalability and market growth will be pricing policies. Compared to the traditional vertical mobility, eVTOL allow for low maintenance and operational costs. The advanced air mobility market is driven by enabled technologies derived both from the aerospace and automotive industries, together with a strong relevance on the urban planning and infrastructures development sectors. Aerospace and automotive have always been the key industries of the touring economic ecosystem. Skygate. Skygate is the first advanced air mobility project in Italy. Skygate is the project with the aim to develop the first example of electric air transport for passengers in Italy while testing new technologies and new service models designed for urban mobility and sustainability. Skygate competitive advantage is the fact that our headquarters is located within the Torino Air City Airport, right in the heart of an important European airspace district. Skygate, in short, is a startup accelerator in the field of vertical electrical mobility. Skygate will support startups and scale-ups to get access to the market, which is traditionally complex, risky, and highly regulated compared to the other industries, by leveraging its aerospace expertise, its aeronautical assets, and certifications. The first Italian vertiport is located, as I told you, in Torino Air Airport. Skygate will offer a validation and in-flight testing laboratory dedicated to all those innovative technologies that need to be prototyped and tested before entering the market. A digital twin for design, planning, virtually simulating and replicating full air mobility ecosystem to be sold worldwide. A unique virtual simulation environment to test vehicles, infrastructures, technologies, and urban planning supported by ENAC, the Italian Civil Aviation Authority, and Politecnico of Turin. Air advanced mobility is not simply an extension of today's aviation industries. It will be enabled to entirely new products and services that will rely on investment and development. Exciting new technologies, from lithium-ion batteries to lightweight electric motors, advanced composites, aircraft automation process, and safety systems enable safe, green, affordable flight, greatly expanding the mobility of people and goods. Proponents of urban air mobility anticipate that advancements in electric aircraft, automation, and telecommunications driven by unmanned aircraft and automobile applications may support the introduction of prototype systems and service networks as soon as 2020. Vertiport is not an helipad. It's the infrastructure for the electrical vertical takeoff landing system. It's a new concept and design of infrastructure for eVTOL. The location of the vertiport will be initially planned and realized near the intermodal transport nodes as airport, metros, fairs, railway stations, logistics centers, bus stations. The new infrastructure for eVTOL will be eco-sustainable as materials will be modular, functionally of the location, as we can share or vertiport or vertiparts, single landing points or hub to optimize an intermodal transport system. Potential customers at the beginning will be businessmen, but then after 2026, a low economic cost compared to taxi car. What we need to understand is that trust and acceptance by citizens and goods future urban air mobility users are therefore critical to the success of this innovative type of transport. Torino Italia Airport is the capital of Italian aviation, with an history starting just after the Wright brothers' flight. Since 1918, Fiat Aviation produced 32,000 aviation engines, 13,000 aircraft sold in 27 countries. Our Torino Italia Airport was the only one until 1966. For more than 40 years, the airport became the main hub for training and one of the most relevant airports for the Italian general aviation. Since 2000, the airport has continuously expanded, also thanks to DigiSky in the research and development field. In 2009, Maurizio Cheli, the founder of DigiSky, won the world speed record with an innovative aircraft with electrical engine called Sky Spark. The Torino Italia Airport is located approximately 3 miles from downtown Turin and is connected by the subway and service public transport. This is the experimental scenario. An agreement with the City Council of Turin, the City Council of Alba and Ivrea will be the first connections with electrical vertical takeoff landing system. Alba and Ivrea are industrial cities with some road and railway connections rather than deficient. An air urban transport from Torino Italia or Torino Caselle, the main airport of Piemonte region, will allow to connect quickly the two cities. Skygate Turin offers an excellent scenario to validate technologies that will see different classes of aircraft and different modes of traffic management. No matter what the technology is, all aerospace innovations necessarily undergo different stages of development and certification, which are intrinsically stringent. The certification path starts from transfer of technology via prototype development with airworthiness check to fly and in-flight test with permit to fly and final certification of a dedicated unit through a flight test program. This kind of hub in Torino, Italia is already set up in other different European cities, as in Ingolstadt in Germany, or in Lyon in France under the Aeropol initiative, or in the UK Cranfield Technology Park, or in Cologne, Bonn, or again in Germany with a partnership with Lilium, or at the Schiphol airport under the partner of Dutch Drone Delta. Here are the first partners that support the Skygate project. There are, on the left side, institutional partners like Polo Technology of Turin, Torino City Lab, University of Torino, Polytechnic Torino, but also the main airport company as Torino Sagat. Regarding the industrial assets, it's a new news released last week that Manta Aircraft, an Italian eVTOL company, will begin the flight test in 2023 in Torino Torino Italia Airport. Another partner will be ENAV and dFlight, the service provider, to develop the first aerial corridor under the digital twin concept. Let's conclude my briefing regarding this question. What are we looking for? Skygate is looking for industrial partners to develop a replicable urban air mobility ecosystem to be sold worldwide. The time schedule for eVTOL activities, Volocopter announced on Monday, 2 days ago, flew the first time in a civilian airport in Paris. And for Volocopter, for the other eVTOL constructors as Lilium or EHang, they plan to have commercialization of air transport, air taxi transport in 2014 during the Olympic Games in Paris. We hope in Italy to begin the air taxi transportation in 2026 for the Milano Cortina Olympic Games. Thank you very much for your attention, and I'm ready to answer to your question.
Okay, thank you, Giovanni. That's a shame that we were unable to show your movie, but we have plenty of time. So if you can try once more, it's not a problem.
Yeah.
Okay. Anyway, I have a question for you. It's mainly related to the last slide when you speak about replicable model. I understand, of course, that Turin is very peculiar because it has, let's say, most of the aeronautical industry in Italy. So maybe it is much easier to do in Turin and so on. But what is how easy is to export this model to other cities? Because also you showed a slide where there are Lyon, Köln, or Amsterdam, Schiphol Airport. And this is the right pronunciation, Schiphol.
Schiphol, yeah.
Schiphol, yeah. Dutch is impossible language, okay? It's very difficult. Okay, so something has already been done, but of course there are some action required to extend this project to outside. So how easy it is, and which action are required to extend?
The goal at the moment is to found not only institutional partners as already signed a partnership with Skygate, but also some industrial assets that could support the entire system of eVTOL. The city airport of Torino, Italia, is a downtown city of Turin, and at the moment there is a sort of negotiations to find specific industrial assets. As I mentioned before, with Manta Aircraft Company is an Italian eVTOL company that will begin the flight test in Turin 2033, but in the same time, there are some negotiations to find other specific assets as for the electrification, for the battery swap. At the same time, there are some negotiations with a big company, aeronautical company, that could support a Skygate project, because the aim is to develop and to put in the market an Italian product with the specialization and the skill of the Italian company. An hub set in Turin and inside the Turin Alenia company could be a sort of strong stimulus for also small companies that are building specific supports for the eVTOL, like the software for the autopilot, for the UTM airspace system. The goal is to find the goal is to have an Italian project that at the end of the experimentation, with the final certifications released by ENAC or by EASA, this project can be duplicated or replicated also in other Italian cities or worldwide.
Okay, thank you, Giovanni. If you want to try once more before I give the floor to somebody else.
I'm not so. Let me try again. Let me try again to. Is on the screen now. The video.
No.
The video is in the screen.
No, but
you are not sharing your screen.
No. I try later, or I can send the video via email to someone. Maybe
yes,
our
please.
colleague can
I will
show to everybody. Maybe it's.
I will write my email.
If you write me
in the chat.
Maybe would be the best idea. Is on the screen now. Is on the screen now.
Yes.
The Aeroitalia airport in Turin bears witness to over 100 years of Italian aviation history. Since 1908, years after the first flight by the Wright brothers, Turin has become a pioneer in the design and production of aircrafts. Fiat Aviazione has produced 32,000 engines and 13,000 airplanes sold to 27 countries. Today, the most important Italian aerospace industrial hub has developed next to the airport. Leonardo, Thales Alenia Space, and Altec are also based here. We too have been present for over 10 years with our subsidiary, DigiSky, a company focusing on advanced avionics systems. In 2009, its founder, Maurizio Kelly, a former NASA astronaut and test pilot, set the world speed record for an electrically powered aircraft, the Sky Spark. By 2035, more than 35,000 air taxis, drones, and unmanned vehicles will be flying worldwide, providing for a combined market worth more than 70 billion euros. Today, in this same airport, Skygate is built on the root of the Italian aeronautical heritage of the 1900s, with the goal of envisioning the launch pad for the vertical mobility of the third millennium. The acquisition of the entire airport area, thanks to the involvement of major investors, represents the starting point point for the development of the first vertiport in Italy and of the acceleration hub where industrial districts and research centers will meet. Skygate will be home and will accelerate projects and startups in the fields of hybrid propulsion, energy storage and management, new materials and new structures, vertical takeoff systems, and autonomous flight technologies, including services for mobility, such as flight planning, training, maintenance, and logistics. Skygate will provide business acceleration services to all the startups and small companies operating in the advanced air mobility market in order to facilitate their access to equity funding and products development. In addition, Skygate will offer airport services certified by the Aeronautical Authority, new technologies in-flight validation and testing services, equipped workstations, and a training academy dedicated to the advanced air mobility professionals in partnership with the Polytechnic of Turin. The integration of aerospace infrastructures, industrial capabilities, strategic development skills, and academic research allows Skygate to become the perfect partner to all those companies that are willing to operate in the urban air mobility market. The arrival of these new business realities in our region will attract institutional investors and will have a positive impact in terms of job creation. Our challenge is, within the next 10 years, to make Skygate one of the first hubs for the development and delivery of urban air mobility services in the world.
So just the last, Skygate project has been created by two companies. One is Always a company that is an investment private company, and DigiSky. DigiSky is a EASA certificate company for design and production, and also for the aerial works they get Expo. But at the same time, they already have some experience on electrical engine and also on electricity support, because in 2009 they developed and project an aircraft that could fly in 2009. Then now we are in 2021. After 10 years, in 2009 they were at very stage of the beginning of the electrical aircraft system. Just to conclude my briefing, and also maybe there are some people that want to ask who support Skygate project, which are the companies.
Okay, thank you, Giovanni. I don't see other questions, so okay. At the end, we achieved the movie. Okay. Okay, thank you, Giovanni, again. So we can, if there are no more questions, we can go to the next speaker. Lieutenant Colonel Konrad Wojtowicz from the Military University of Technology in Poland. He will speak about military cadets and officers training on metrology. Konrad, thank you very much for coming with us, joining us, and please, the floor is yours.
Morning. Morning, everyone. Thank you very much for inviting me for this noble society. Let me share my screen, presentation. Okay, can you see the presentation?
Yes, we can.
Great. So again, I'm Lieutenant Colonel Konrad Wojtowicz. I'm the Associate Dean at the Faculty of Mechatronics, Armament and Aerospace at the Military University of Technology. And in this presentation, I'd like to focus on our main product, which is military officer, young military commissioned officer. There are a lot of changes, have been a lot of changes recently in our course of study. So I'd like to present it briefly and sum up with the offer for foreign cadets and the foreign commission officers about the professional courses. So briefly about us, Military University of Technology is civilian and military university. It means that we train both civilians and military cadets. It's located in Warsaw, Poland, and it's exactly 70 years old because this year is our anniversary. There are 8 academic faculties at the university, and you can see in the names of the faculties that our university is a genuine university of technology. It means that we are a strict polytechnic. Yeah? It's quite important because it's a bit different than in other European countries. Almost the Romanian Military Technical University is similar. Other countries provide the cadets with other course of studies. They train either leaders or use the civilian graduates to implement them in the military system. So in our university campus, we have many lecture halls, laboratories, classrooms, yeah, and there are also almost 1,000 scientific staff supported by more than 300 non-academic research and technical staff supporting our research projects and educational process. Well, I'm talking about it to show you the presence of Military University of Technology between other universities. So taking into consideration the civilian universities, we are somewhere in the middle. Maybe we are even the small University of Technology, small polytechnic, yeah? But taking into consideration military universities, we are quite a big military university. So we are conducting the high-scale modernization process over the last years. And our laboratories are pretty modern currently, containing the lecture halls and laboratory classes, completely renovated library and military training facilities. The students at the Military University of Technology are still mostly civilian. So in yellow and in red, you can see civilian students, and military students are in green. So you can see that there have been more and more military students recently. However, it's still much less than civilian students. It means that we are strictly stick to the civilian requirements in the market. We train students in over 20 fields of study and more than 90 specializations. Not all specializations are available for military students. Of course, we train military students in these fields of study, which are required by our Ministry of Defense. And among others, there are aeronautics and aerospace, which is the main scope of our today presentation. There is another interesting and pretty new field of study, unmanned systems engineering, and it's provided also by the Faculty of Mechatronics, Armament and Aerospace. However, it's not in the military area so far. So I will focus on aeronautics and astronautics so far. What's new in our program, in our curriculum for military students? From starting with in 2 years, we provide military students with the full 5 years master studies. So they get 3 modules in 5 years. It means module of military education, module of directional education, and module of specialized education, with the number of teaching hours, as you can see in the picture. And what's also important, in my opinion, the module of directional education, where most of the engineering, the technical subjects are included, is common for civilian and military students. So if you take the program of, for example, aeronautics and aerospace with some standards and complying with the ON system, so we provide the same program for our military students. So they get nothing less than civilian aeronautics and aerospace specialists get. It means that they are the same engineers, the same graduates at the end of the studies as their civilian colleagues. But what is more, they get additional almost 2,000 module of military education panel. Yeah? So, well, maybe it's not so good, but they get a lot of teaching hours during the program, and they have to consume all of it. Okay, moving on to our cooperation and our offer for foreigners and for foreign military and civilian students. Currently, we cooperate with 15 military universities all over the Europe. The agreements listed here are bilateral Erasmus Plus agreements. However, we cooperate not only in Erasmus framework. You can see most of European countries here. Unfortunately, Italy is not here, so maybe during this upcoming year we could change it, and during the next conference we add one of the Italian universities to this list. I'm really looking for it, adding one of military universities. I know that the problem is not in the will, but mostly in the way of providing your cadets with the technical education and in your system of military technical personnel education, but maybe we could think about it. Of course, we cooperate also with many civilian universities. Currently, it's more than 50 civilian universities, but well, during this presentation, let's focus on military only. So moving on to the Faculty of Mechatronics, Armament and Aerospace, who is a provider of the aeronautics and astronautics field of study, and also unmanned systems engineering, as I mentioned. The faculty provides also students, military students, with mechatronics, field of study, and safety engineering. Maybe the names of fields of studies doesn't sound military, but looking inside the specialties, especially in mechatronics field of study, are strict military, because it's in missile technology, in small armaments, with armament technology, and so on. And similar is with aeronautics and astronautics. As I said, the technical background of aeronautics and astronautics is the same as for civilian students, because the military aircraft is the same aircraft as the civilian one. However, we focus on the military aircraft, considering the cadets education in this field of study. Our internal agreement says that at this faculty, more than 60% of classes are hands-on labs. I'm proud of it because I know that it's not common, even in technical universities, even in polytechnics. So this is it here, because we are pretty well equipped with the laboratories and measurement in it. So we can deliver such a course with such a number of practical hours. Next, we are part 147 training organization, approved and qualified by IEEE. What's more, we are organization #1 in Poland, part 147, that we are eligible to provide students with part 66 license, which is required for personnel, maintenance personnel in aviation worldwide. But even more interesting is that our aeronautics and astronautics field of study is fully compliant with part 66 license. Doesn't mean that we limit to the requirements of this license in our panel, not at all. Opposite, we provide the full armament and airspace program, but our practical approach to this this program, to this field of study, allows IEEE to certificate us and our curriculum of this aeronautics and astronautics program as the fully compliant with part 6 license. It's very comfortable for our students because after being graduated, they can only get the internship and they can start their career in as the maintenance personnel in aviation. And what's more, it's also interesting for our cadets, for our military cadets, because in Poland, in Polish system, you have to be a commissioned officer working as a maintenance personnel of military at least 10 years after being graduated. And the average is about 15 years. So you are getting retired being quite a young specialist. And very often our graduates, military graduates, get the civilian internship after completing their military career as the maintenance personnel and start the civilian career as the maintenance personnel with the part 6 license. Okay, next to the strict metrology in our program, we start our course with the intensive metrology training. It's a 3-semester training. First, and at the first year of study, we provide students with basics of metrology, and then during the second year of study, 2 semesters of metrology. Our laboratories are, I mentioned that they're pretty well equipped with the modern measurement instruments and units. So each student during the classes is equipped with its own measurement equipment. It facilitates our classes, and instead the classes are full of students. All of them have each own task and can work on their own laboratory, with their own laboratory schedule and scheme, and they can get the most from each class. However, metrology is only one of the examples of using measurement during our course. Frankly speaking, most major of our classes and subjects in this course are based on metrology. And I'd like to give you a few examples of our laboratory classes, which are the basis of subjects provided in this course. And you can assess with your own that these classes are designed for measurement and prepared for providing students with measurement tasks. So first, the power systems laboratory, where students can work on power supplies, electric engines, measuring all the power parameters. What you can see in each our laboratory is the aircraft power supply panel. So in each class, we have a panel which where we can get from the wall all the electric powers used in aviation. And what's also interesting, in both sides of former block, yeah, so our wall gives us the power from eastern side, post-Soviet aircrafts, and from western side. It's because we are equipped still with both kinds of aircraft. We have to prepare our students to maintain both post-Soviet aircraft and the new income and new purchased aircraft from the NATO countries. And similar is in other laboratories. For example, aircraft propulsion system laboratory equipped with cage test beds or static tests of airframes, which are of sensors ready to stick on the airframe and getting the measurements. Of course, as you can guess, this hand is designed mostly for research, and the aircraft inside is one of our research. However, our students can involve the research, and we try to prepare the classes and design our laboratory classes in a way that the students can involve in some part our works prepared for the research. And again, in the right, the ground vibration test, also in the cage with other airframe, with a lot of sensors applied on the wing. And of course, at the other end, there is the measurement unit equipped with national instruments, equipment, and with LabVIEW software prepared for getting the result. Then below the engine test bench, and this is strictly the laboratory test bench for students. So students during the laboratory can use it to test and measure the parameters of the engine. And something pretty innovative, the linear electric drive, which actually can't work without sensors and without measurements. So it's a brilliant example of using measurement in operation of the drive. Then aerodynamics laboratory with subsonic wind tunnel here in the picture, but there's also the supersonic wind tunnel. The other stands for testing the airflow during the body. and then greatly equipped laboratory of propulsion systems with models of more known engines in the aircraft. And also here from both sides, the eastern side and western side, we are proud of this laboratory. And here students can not only look at the engine, but also look inside the engine and learn how the engine works. Then laboratory of control systems, which is based on the National Instruments Quasar equipment powered by LabVIEW software. So the students here can prepare their own algorithms for flying the drones, which is binded in the station in the stand, and then train it with the software and hardware during the classes. Of course, the control system course is also supported by other tools, other software and hardware tools, for example, MATLAB. So the students get all the required knowledge in terms of system. Laboratory of simulators is equipped with civilian aircraft simulators of Airbus A320 and Boeing 737NG. It's equipped with the simulators of ground control station of UAVs. It's equipped with EASA certified simulators. EASA certified, it means that the simulators are ready for training pilots in some hours of their trainings. But what's the most important in this laboratory is that our students, our future maintenance personnel officers, they don't work on these simulators in the laboratory. They don't work with this simulator. I'm sorry, they work on these simulators. So they can look inside the simulators. They can develop the additional panels, the additional modules, simulators, or even, as you can see in the right, they can even try to build it from scratch. And the example here is this F-16 jet fighter cabin simulator. Then the laboratory of navigation, where we, of course, work on the currently used in the Polish Air Force systems from the Polish Air Force aircraft. However, we also developed the new navigation methods of internal navigation based on structured light sensors, laser module sensors, and our students in their project classes, mostly in robotics, but also in the embedded systems, can design and develop systems using these modern navigation methods embedded in their robots flying or driving. It depends on the specialty of the student. And the faculty, the university is equipped with an airshed with both military and civilian aircraft. And the shed is not only to show the students the aircraft, but the students are intensively involved in the classes, in the training, practical training in the airshed. It's 1/2 of the year, one semester full of the, we call it integrated practical laboratory, and in this semester, our students spent all their time in the airshed, performing mostly the maintenance operations. So they get the Air Force manual, and the civilian students, they get the part manual, and they perform the operation on the aircraft following the manual. And they have an opportunity to work with both military aircraft, civilian aircraft, fixed wing aircraft. Here you can see some works with the wheel of the aircraft performed by our military students. And here with rotorcraft, replacing the rotor blades in the rotorcraft. And again, our military students. And here again, working with our training jet aircraft, the Spark. And the students perform the operation not only with this scheduled maintenance operations, they are trained also to perform some repairs. And here is the example of such a repair with the rotorcraft engine. So they get the scheme of the engine, they have to identify the malfunction, and then plan the repair and then perform it. Of course, the malfunction had been previously provided to the engine or the other part of the aircraft. So this is very practical and very educational course of action. There is the whole specialty within the aeronautics and astronautics field of study, air armament. And the students of air armament have their own laboratories with air missiles, air rockets, bombs, and guns. Out of the Airspace Institute laboratories, there are also laboratories and workshops connected to our branch. Very interested, and this is why I'd like to show you some scraps of it. First of all, this is the virtual missile laboratory, where the students can get involved inside the missile and even get out some parts of the missile to get familiar with the parts which are inside. Another one is robotics workshop with industrial robots, but also with mobile robots, which can be redeveloped and reprogrammed by the students. And then the virtual robotics workshop, which is similar to the industrial robotics workshop. It's actually the same, but it can be operated by VR, which is also quite informational for the students to prepare them for the real laboratory. So first they work with the virtual robotics workshop to move to the real one in the next step, during the next classes. Okay, you can come up with the question, how could you involve with this laboratories, with these classes, with this course, so with your students? It's possible, of course, within the Erasmus Plus program, and I'd like to shortly present the forms of cooperation within the Erasmus Plus program currently, and a few words about our plans for the near future, very near future, because the plans are already happening. So, for now, we offer all abroad students or the foreigner students, both military and civilian, 6 subjects, which can be put together and construct the full semester funded by Erasmus Plus. So your students can get the subjects from the list, whatever they want, and whatever comply their original semester at the domestic university. Why this approach? Because there is very often the problem with compliance between the domestic semester and the semester abroad. And to facilitate this work for the Erasmus Plus coordinators at the universities, we offer all our subjects to the common offer, and each student can choose and complete their own curriculum for this one semester. So it can make it as compliant, as similar to the original program, and as acceptable by the Erasmus coordinator as possible. Okay, what more for military students, for military cadets? Accommodation is free. So the military students applying among the Erasmus Plus program gets the money from Erasmus Plus as the civilian students, and he or she gets accommodation free. He is eligible to get meals in our military canteen, where it's very good and very cheap. And as I said, it has to only select some of these 16 selectable subjects. It's the first form, the full semester. But we know, we are aware, and we have the same problem, and this is why we are aware of it, that for military cadets, it's quite often a challenge to send the students for the whole semester because of military training, because of some specialized training for subjects during the semester. And that's why we prepared the 2 months length military airspace internship on airspace technology. And it's prepared every year in the autumn. It's offered within the EMILIO, European Initiative for Exchange of Young Officers, which are a part of, and some of your universities are also part of, So within this EMILIO framework, we offer this internship, which can also be funded by Erasmus Plus. Erasmus Plus can fund the internship not shorter than 2 months. So our internship is compliant. So you can send your students to this airspace technology internship. The offer is on the EMILIO web page, so you can find the specific curriculum of the internship there, so you're welcome. And this is what we can offer now, these 2 forms of activities, the full semester or the 2 months internship. And more about the internship is that it's 2 hours in total, which 156 hours is with supervisor, and it's divided into 1-week blocks in fundamental of control theory, design and simulation, printed circuit boards design methodology, rapid prototyping, modeling and reconstruction of airframe, fundamentals of aircraft designing, some issues of airframe, aircraft maintenance, and aeronautics and astronautics technologies. And these 1 week modules are supported by 1 day scraps of insights laboratories in simulators, airspace construction technologies, aerodynamics and thermodynamics, air armament systems, robotics, CAD, and some issues of special military system. And as I said, the specific curriculum is on Emilia website. And again, being aware of this threat for military program, military course, when the military cadet is sent abroad for whole semester, this year, and actually the end of last year, we started a project of preparing a European common technical semester for defense and security. The project is led by Military Technical Academy and the participants are French Air Force Academy on the Provence, Hellenic Air Force Academy in Greece, National Military University Veliko Tarnovo in Bulgaria, and European Security and Defense College in Brussels. And the college is an associate partners, which is important because, of course, the project, the grant is granted, has been already granted, and the main performers are designed, are designated, are appointed, yeah. But each of you can join the project as an associate partner, as the European Security and Defense College did. So you are welcome to join the project as the associate partner and have some impact into the program designed in this project. Even if you don't want to join as an associate partner, you can still use the outcome of the project, because the outcome of the project is to be the curriculum of the European Common Semester, the scientific and teaching materials for teaching in the subjects included in the semester, and the network of scientists and teachers working together for the project. So in 2 years, in 2022, the outcome, when the outcome is ready, you can get it and implement it in your university, in your national program of studies. And what does it mean that you implement the semester? After the implementation, one of the semester in your course is to be the same as the semester in the other universities, other military universities, technical universities in the involved countries. It means that you can send your military cadets to one of these universities, and you are sure that the curriculum of this semester, the program of this semester, and all the materials, all the content of the subject is as you designed, is as you expect. So you are not surprised with the quality of this semester or with the content of this semester, because all of that has to be negotiated and discussed before. The project is ongoing. It has just been started. Some curriculum has already been designed and proposed, offered by the partners. But of course, all is open for your suggestion and for your cooperation, so you are welcome. And at the end, Military University of Technology is focused on teaching military and civilian students. However, it's also quite active in research activities. And only some scrap from it. We are a national center for space and satellite engineering, and our priority research area is space technologies with construction of satellite devices and systems, research and implementation of new materials and technology, development of terrestrial systems, including IT systems for aeronautics and airspace, and the satellite techniques, including navigation, telecommunication, Earth observation systems. And other branch which would like to show off with is we are an engineering center where we provide priority research areas, introducing new technologies in the field of biomedical engineering to the Polish market. We share R&D infrastructure with members of the cluster, and we offer the consulting and creating databases in this branch. Thank you for your attention.
Okay, Conrad, thank you very much indeed for your exhaustive briefing. I take it as a wish the exchange between Italy Air Force, Italian Air Force Academy and the Polish one for the next years. So thank you very much again. And now we go to the next one. Lieutenant Colonel Ferdinando Dolce is talking about EDIDP program, in particular space situational awareness projects. So Ferdinando, thank you. The floor is yours.
Good morning, everyone. Can you hear me?
Yes, we can.
Okay, perfect. Thank you very much to, first of all, to the organizing committee and to General Nicolella for the invitation to this event. I'm very happy to give you today this presentation. Now I will going to share my screen. Before to do that, just a very short introduction. I'm working in the Italian General Secretariat of Defense, or in the National Armament Directorate, in the 4th Department. And I'm currently working in the Space Cooperation Office together with Colonel Iovino that supported me in this task. And I'm head of Space Situation Awareness and Space Innovation section. I will now share the presentation. I hope. No, just a second. Can you see my screen?
Yes, we can see it.
Okay,
this is the full screen of your presentation.
Okay, perfect. Thank you very much. So the title of my presentation is EDIDP and actually also EDF program with the focus on SSA project, Space Situation Awareness project. The objective of the presentation is to give you to share information on these new European Union defense cooperation tools, and especially in space domain. And these tools are exactly EDIDP and EDF programs. And the scope is to go into the details of some EDIDP project proposal currently under the assessment of the European Commission, and we hope to receive very soon the feedback of the European Commission on this project. So in order to do this, to do that, I will start with the general overview. I will give you a background on how European Defence Fund, a European Development Industrial Program was created, and how the project and the program is managed by the European Commission, and what's the role of the Italian National Armament Directorate in this framework. And then I will give you also very short overview on other EU cooperation frameworks. And finally, I will give you some details on this project proposal on space situation awareness, preparing the floor to the next speaker that will give you further details on one of these project proposal. So everything started in 2017. The little spot that you can see now in the screen is related to the PADR, Preparatory Action Defense Research Program, started in 2017, as I said before, a biannual program limited, let me say, to the research window on defense, and with an overall budget relatively small, 90 million euro. The preparatory action on defense research was followed by European Defense Industrial Development Program, EDIDP. That was closed actually last year, so it was 2019-2020. And the second wave of EDIDP, the one in 2020, is currently, as I said before, under evaluation of the Commission. The project proposals are under evaluation of the Commission, and we are expecting to receive feedback very soon, by the end of this month, hopefully. So EDIDP was a bigger fund, 500 million euro, but even EDIDP was a preparatory action for the European Commission before to launch a much bigger program, European Defence Fund. The European Defence Fund is starting this year and will cover both research and capability window with a different percentage. 70% of the fund would be dedicated to the capability window, and the 30% of fund will cover research window. So we are talking about communitarian funding for industry and research center working in the defense domain. The program in the fund will cover the R&D, research and development cycle, and with the exclusion of the procurement of the product that will be developed with this fund. So the acquisition and of the system that will be developed with this budget need to be done by the member states with their own national budget, and eventually the Commission will support this procurement with some toolbox, but the procurement will be in charge of the member states at the end of the cycle. So the main goal of European Defence Fund is to enhance defence industrial cooperation at EU level. So it's a bit disruptive objective for European Union, and also in both research and development window, even if the capability window is bigger than the research one. And EDF is targeting the development until up to the prototype and certification phases, so quite forward. So, as I said before, EDIDP was a follow-on of preparatory action, and the budget was relatively small, 250 million per year, so 500 in total. and the both were preparatory program. EDF is a 7-year long program. Similar rules of preparatory action and EDIDP. So the preparatory action in EDIDP basically gave the opportunity to the member states, to the defense community, to the Minister of Defense to understand the mechanism, to understand the bureaucracy and the administrative tool to set up in order to achieve and to manage the European fund, because the MODs of European Union were not used to manage such kind of financial supports. And now we can see that more or less we are ready to start with EDF, with a bigger program, 7-year long. As you can see my slide, we are talking about more or less 1.1 billion per year, billion of euro. So it's very big program. The first call of EDF will be published this year, quite soon. Also, this the publishing of this call we are expected to be in the next weeks. So between the end of July and June and July. What are the requirements to set up a consortium that can apply to EDF? First of all, maybe I did not pointed out that this is a program for European industry and research center working in defense domain. It's not for the MOD. It's not for the governmental part that can get access to the fund, but it's for the industry to work together with the MOD or for the MOD. So to set up the consortium, there are several requirements. The main one is that you have to, the consortium need to be composed at least by 3 different entities located in 3 different member states of European Union. So we are talking about European Union, and you can imagine very easily the impact of Brexit in this scenario, because the link with the English industry in defense domain was quite strong. The management facility and asset located in Europe must be located in the European Union, and for the capability window you have to you need 2 member states that somehow commit or declare to be interested in the project proposal. So a letter of intent usually is attached to the project proposal with the MOD that declare to be interested in this project proposal. As far as the third parties, as I said before, UK and eventually also United States inclusion in the project proposal, some of the negotiation was ongoing. It's a political issue, but so far the rules are quite clear. You have to be compliant with some strict rule, in particular the Article 7.6 of the regulation that basically says that the interest of the project must remain, and the outcome of the project must remain the European Union. And above all, you cannot get access to the fund. You can eventually be part of the consortium, but without receiving European Union funding. So the funding rate for EDIDP and EDF is summarized in these slides. For the R&T, so research and technology project, talking about technology readiness level lower than 4, up to design phase, the funding is 100% of eligible cost of the project. For R&D, so research and development project, the technology readiness level is starts usually from 4 and up to study and certification, from study, sorry, to certification and prototype phase, and can be funded with a percentage that can change from 20 to 80% of eligible cost. Now, in the next slide, there is a table that summarizes this funding rate. It's a bit complicated to analyze now during my speech, but you can see how the R&T window can reach the design phase and is 100%, as you can see in the red boxes, 100% of the funding, and TRL is about 4, or at least lower than 4. And the R&D can achieve the certification qualification, and usually the percentage is lower than 100%, can achieve 100% under certain condition, and specifically for the development of technology disruptive or that can increase the efficiency across the life cycle of defense product and technologies. In this slide, I would like to share with you what are the co-funding mechanisms that so far the member states and the MOD put in place for EDIDP and for EDF. So you can see here an example of a project where we have 3 member states, 3 MODs supporting and participating to the project. So Italy, France, and Germany, for example. And then for each project, there are some of the costs that are eligible for the funding, for European funding, and some other costs that are not eligible. So first of all, the cost of the project need to be split in eligible and not eligible costs. The Commission can grant only the green part of the project. The red and the yellow part need to be funded or co-funded or by the beneficiary, the industry or the research center that is proposing the project, or by the member states or any other entity. So in Italy and also in the big country, generally, if the project is of interest, we try to co-fund the project. But this is not it's not a must. Can be. There are also some cases where the industry and the research center co-fund themselves the project. So how this process is implemented? First of all, the EDF cycle is annual. So every year there will be call published, more or less this period, June, July. And how the call are developed. There is a program committee for European Defence Fund where the member states and the MOD have all the member states of the European Union have a representative, and the work program on the top of the in this part of the screen, the work program has been is the first phase of the cycle, and in our case, the Secretariat General of Defense, the third department, is the Italian representative of the work program to set up to agree a work program. The work program identified the topics in the area to be funded, and then there is the publication of the call, and also in this case, the call, the requirement of the call. Can be supported by the staff of the European member states, European subject matter expert or defense. So in this case, in Italy, is the 4th and the 5th department, depending if the call is for development or research window. And then the third, after the publication of the call, then the consortium need to be created. And the project proposal need to be developed together with other member states. Usually the time is not so wide. You can have about 3-4 months to set up the project proposal. You have to consider that you need to federate with other entity of other member states. So sometimes it is required. It's not so easy. And then you can submit your project proposal. Sorry, in this space, the National Army Directorate and the Secretariat General of Defense can support the industry eventually to set up the project proposal, and if the proposal is in the capability window, we make an assessment and eventually provide a letter of intent declaring that we are interested in this project. So it's quite important, because the letter of intent of at least 2 member states need to be attached in the project proposal. And I say at least, because usually the number of the letter of intent have to be much higher than 2. So 2 is really the minimum level. Then after the evaluation that is performed by independent expert, there is a ranking list, and then the grant agreement and the action management, so the project management, again with the support of the MOD staff that are in the loop, keep tracking of the project evolution, and eventually need to support the co-funding of the MOD in the project. All this new program, EDF, is managed by the European Commission, and in particular by DG DEFIS, Defense, Industry and Space, Director General Defense, Industry and Space. This is a very, very new Director General, born in the 1st January of 2020, merging some services of DG GROW, dealing with the defense and space topics, and it is under Commissioner for Internal Market, that is Mr. Thierry Breton, together with DG GROW and DG Connect. And the Director General of DG DEFIS is Finnish, Mr. Timo Personen. The staff of DG DEFIS, for your information, is about 210 people. This information is about 1 year old, so maybe now we have more people. And the operational budget is roughly 4 billion euro per year, just to manage the staff and the DG. Now in this slide there is an example of a call for proposal, because I would like to now give you an overview of other EU framework that are also linked with EDIDP. You can see this is one of the call related to space situation awareness that we will go. I will show you later on. About 20.5 million euro for 3 topics, and as you can see in this call for proposal, in the green, in green, there is a clear reference in the capability development plan of European Union. So this is quite important, because we should take into account the level of ambition of European Union is strongly influencing the topics of EDF. So the work program need to be coherent with the European Union capability development plan. And so what's this CDP, the capability development plan? And now to explain you quickly this new concept, I have to open a bit another window on other EU framework. So the EU CDP, first of all, is currently the main reference tool and a sort of a trigger or hook. You can call whatever you want. It's something. It's very important to identify the EU capability military needs to support EU common security and defense policy. This is very important, because not all the topics can be funded or will be funded in EDF. All the topics of interest of defense of the MOD of European Union. So we are talking about common security and defense policy of European Union. So the CDP give to the member states an assessment on the long-term capability needs at the EU level. So this is something somehow similar to the NATO process, with a lot of difference, of course, because the European Union is it's not an operational branch of European Union, operational branch of defense. The CDP is usually 4 years valid, and the last one was in 2018. So maybe this year we start the process for the definition of the new CDP. And the CDP, a key role in the CDP definition is played by European Defence Agency. That is not a commission agency, is an independent agency born mainly to foster the cooperation between the member states in defense domain, intergovernmental cooperation, so without no communitarian budget, so budget of the member states. It was funded in 2007 under the treaty, the Lisbon Treaty. It's, as I said before, it's a European agency funded by the member states, by the MOD. We have a steering board, the TDA, composed by 26 now defense minister, and there is a link with the other EU institutions like the European External Action Services. So EDA has a key role in the CDP development. So that's why I would like to point out this link, because the CDP is actually developed with a big contribution of the staff of European Defence Agency. Moreover, EDA is also used by the member states to launch R&D cooperation, usually with a limited small group of member states, 3-4 member states that can set up, can co-fund a project of common interest. Now, let's move quickly to the last part of my presentation, so the relevance of space situation awareness. If you were able to attend the presentation of Commander Reversi before me, in his presentation was already pointed out the importance of SSA. It's the new pillar of the space domain, but now after the declaration of NATO as a space, as an operational domain, SSA is increasing in its relevance. Space, as said by Commander Reversi, is more and more a competitive, congested environment, and so is moving from a pure R&D or service provider or enabling domain to an operational domain, meaning that in space you will perform operation. And the first step to conduct an operation is to have a recognized space pictures, an SAA, situation awareness. You must know the environment where you are operating, where you could receive threats, and you must be aware of what are the threats, the intentional one and the unintentional one, in order to put in place action to react to these threats. And that's why in EDIP 2020, there were one of the biggest funding was on SSA, on space situation awareness. Now there are projects under evaluation, and the total budget on this topic of the Commission was 22.5 million euro, divided in 3 topics. One dedicated to command and control SSA, and together with the process and exploitation services and data. The second topic was to enhance SSA sensor in order to enabling identification and characterization. So something that is a bit different from EU SST. I don't know who of you is familiar with these services, but it's in this project. The idea of the Commission was to fund development of a new sensor that can go beyond tracking and surveillance, but also up to identification and characterization of space objects in all the orbits, geostationary and low Earth orbit. And the third topic was early warning against ballistic missile threats for ballistic missile defense. There is a bit an overlap between the BND and SSA, and the overlap is not only related to the environment where these threats can act, but it's related also to the fact that a ballistic missile can be quite easily used also to target a satellite. As this was done in the past as a test by, as we know, as many public available information that China and India did this exercise with success, producing a lot of debris in space. But basically, the ballistic missile can be used also against satellite. In this perspective, it's part of SSA to be aware of the threats that can come also from the Earth to the space. So now very quickly, I will give you an overview. Further detail will follow on topic 1 in the next presentation by Leonardo Vitorcicet. But basically, in topic 1, we are now we proposed and we supported a project called Integral. The purpose of the study was to develop and to test some tool for sharing and exploit SSA data. There is a quite big consortium led by Italy with France, Germany, Spain, Poland, Latvia, and Denmark. And the Italian main beneficiaries are Leonardo, Telespazio, Cira, and GM Spazio. And in this slide is more or less there is the how the data and service and information should in the project proposal are proposed to be exchanged between the different stakeholders of the European architecture, taking into account also the information coming from a USCT sensor. And we hope to receive a positive feedback on this project proposal very soon, so that we can start this quite ambitious project. Very quickly, because the time is going very fast, the second topic was on new SSA sensor, so no SST. As I said before, there is a project here where we are supporting, led by France, that is called Sauron, and the outcome here is the same: to study, to develop and test a new SSA military sensor and no SST, and eventually also space-based. The consortium is led by Ariane Group in this case, and again there are many member states. Just to give you an idea of the range of the consortium, in EDIP project, in EDF would be more or less the same, even more. And the beneficiary in this case are Leonardo and Thales Alenia Space, Italy. We are proposing some multistatic radar, monostatic radar in L-band, EASA L-band, for detection and characterization of threats. And also we are studying new space-based sensor for the detection of RF threats. Again, this is still a project proposal. Unfortunately, we are not officially awarded by the Commission, and so finger crossed we will receive this feedback very soon. The last, I think we can switch this presentation, this slide, simply saying that we are targeting to prototype and to test some of the sensor and plus the design of monostatic radar in L-band. We have the third topic, early warning space-based. Again, here there is a very big consortium led by OHB Italy. This is just a study. And for Italy, we have MBDA, Leonardo, TASI, and OHB. And also here, for Italy, the main outcome that we are expecting is an early warning command and control system, a dual early warning BMD space-based sensor infrared linked to SSA capability. And again, we are talking about a study at the moment, a feasibility study, and then also the design and the study of a small spacecraft for the early warning mission. So in conclusion, apologize if I was a bit too long. We can say that EDF represents a big opportunity for the EU funding for industry and the research center working in the defense domain. The objective is to foster EU cooperation at the defense level, so opening a new box at EU level. defense capability and research development. It's also a very ambitious target. So we want to fund a project that will be able to, I would not say to be a game changer, but at least to contribute to the capability development of our armed forces. And then this is also EDF will be, of course, will pave the way for a standardization process at the EU level in defense domain. That is something that is missing currently. Last but not least, space domain is in one of the top priority in the EU agenda. So the topic, and in particular the SSA, will be certainly in the following project call in the next year. And with this slide, I conclude my presentation. If you have any question, I will try to answer, and I will do my best to satisfy you. Thank you very much.
Thank you, Ferdinando. I think some question will come after the second part. Anyway, I think because you gave a clear picture of the new, we call battlefield. So the space is becoming a real, a further battlefield. So some concepts have been extended, like situation awareness, early warning. So it's becoming really a complex one. So thank you. Let's go to the next military space situational awareness. Advanced Space Command and Control Capability in SSA from Giulio Troso, Leonardo Vitrocisete. Giulio, the floor is yours. Thank you.
Okay, good morning, everybody. Can you hear me?
Yes, we can.
Okay. So good morning again. I'm here with my colleagues Marilena Fittipaldi and Antonio Romano. And thank you, first of all, thanks to the organization for this opportunity. We are going to, sorry for wearing the masks, but we are obliged to do this since we are in the same meeting room, so we can share the presentation we made. Apologize about that, but I mean, it's these are the rules. So our presentation of our paper, I'm going to share the screen, our PowerPoint. Can you see it?
Yes, we can see it. Just put in presentation mode. Okay, that's right.
Okay. Okay, so this presentation is say a strict follow-up of the intervention made by Lieutenant Colonel Ferdinando Dolce, who is, by the way, one of the authors of this paper. And this address let's say the advanced system command and control capability in space situational awareness. This recaps is contained, I mean, some elements that are parts of our proposal that we made in the frame of the DIDP context, as presented by Ferdinando Dolce previously. So the idea here is to give you a technical focus on the capability that we jointly developed together with MOD and with other industries in this domain. Vitrocisete, as anticipated by Ferdinando Dolce, is the leader of the consortium that answered to the call SC2 of the DIDP program. So basically, the scenario, I will be very fast because it has been introduced very well here. The space domain today is not only an opportunity of development of technological development, but more and more a theater of military operation. And in this scenario, the space situational awareness represents a key element, as it's the capability to focus on the knowledge of the space. Here in our work is mainly related to the military, to the military space. So we are interested in the orbiting objects that are capable of offensive action. But of course, it doesn't exclude the space debris population that are also can have impacts on the operation. At European level, it has been recognized the need to increase the comprehension of the space situation, and the SSA command and control has been identified as a solution to achieve these European needs. SC2 are advanced surveillance systems that are capable to understand and explain and finally predict what happens in space. That are basically, I mean, can be explained in a keyword that shared recognized space picture. Our work, as described in the paper, starts from the gap analysis. As recalled by Ferdinando Dolce, the 2018 Capability Development Plan has identified a significant gap in SSA domain, and identified as well the need to increase the capability to protect member states by preventing natural and intentional threats. So the European member states basically are looking for more effective SSA capabilities to detect, characterize, and track objects in space. Here I would like to stress the keyword characterization, because the real purpose of this kind of system is to understand what is happening in the space. So not only detect and track, but also identify and characterize the object. And a huge effort has been done by the European Commission to put in place the European framework, ADIDP, and later on ADF, European Defense Industry and Development Plan, where the joint action of the MOD of the participating member states and the industry will have the opportunity to study, design, and develop SSA capability. Again, I want to stress that here the scenario is much more oriented to the defense purposes. The suggested direction that has been identified goes toward the realization of SSA command and control system capable to acquire and process data coming from different sources that can be sensors, basically national sensor, and data extracted from catalogs that can be existing catalogs or new catalog to be populated. Doing this in order to monitor the space situation, identify and detect threats, understanding any anomalous behaviors of the orbiting object with respect to the planned ones, and very important is allowing cooperation among member states, because let's say the framework in which we are working are based on the cooperation among member states. In this specific technology, the cooperation is made by sharing data, products, and services. Again, we are back to the keywords recognized space picture that basically provides the complete knowledge of what's happening in space, and represent a key elements that contributes to a military space intelligence capability. The guidelines for our development is goes in the direction to use innovative approach and technology in developing capabilities like the data fusion, threat and anomaly assessment. We are planning to use artificial intelligence and machine learning techniques to improve the capabilities and the performance of our algorithms. Another guideline is to develop and establish new services and functionalities. So by our target is to develop something that today does not exist, at least with an European at European level, that goes in the direction to monitor the space and identify the threats. Innovation will be strongly used in the capability development, in detection, tracking, and characterization of the object. And the last but not least, the guideline is to have system capable to cooperate with already existing system, because the idea is not to go on overlap with already existing capabilities, but creating something that can be can generate value to the existing and to the state of the art technologies and system. One important point is the complementary with another framework that is oriented to the space space awareness and tracking, which is the AuSST. Whereas the AuSST is much more oriented to the detection of the space debris. In our SSA domain, our focus is to establish a military intelligence capability to understand what's happening in the space from much more from the military standpoint, and characterize and characterize the object. Okay, this is the introduction. Now I will leave the floor to, we will enter in the more technical session where we are going to describe four capabilities that are a subset of the overall capabilities that we are planned, and we are that are part of our overall view. But we choose four capabilities that we believe represent, I mean, key elements for in the perspective that I presented.
Good morning. Can you hear me?
Yes, we can.
Okay, this is the first capability. It is going to detect potential threats, suggesting the most suitable action to cope with through the following activities. So in this slide, we can see the whole life cycle of the threat assessment. The first phase is the detection of the threat, followed by the characterization of the threat itself. Then there will be the initial assessment where we are going to understand how to neutralize the threat, followed by skills management, useful to develop alternatives to neutralize the threat. And at the end, we will have a follow-up that will be very useful to assess whether the chosen alternative has been effective. So this, in this way, the life cycle can be described and summarized. Next slide, please. This capability, threat assessment, will be also focused on identifying unexpected and suspicious events and potential dangerous activity in space. And this identification will be based on the following activities. The first will be the detection of closely spaced objects. Then we are going to detect suspect events as altitude change and altitude variation. Then another anomaly detection that we are going to address is co-orbit satellites, followed by closed approach of a high-value asset. That can be, for example, a ground sensor or a space-based sensor. In case a maneuver is identified as not suspected, we are going to perform a deeper analysis of its nature and intent by identifying the function to minimize or maximize. To do this maximization, we can use techniques as reinforcement learning, where the objective is to determine the reward function that guides the behavior of the space object. It's known that in reinforcement learning there will be an agent, one or more agent. This agent will explore the environment. As soon as the agent will go through the maximization of the function, it will be rewarded. Otherwise, if he goes in the wrong direction, he will be punished. In this way, as soon as the agent explores the environment, he will learn which are the best action to take in the direction or maximize the function. Next, please. Okay, the threat analysis will be also focused on RF space-based threat detection, in particular signal intelligence, for example, hostile actions aimed at disturbing communication among allied satellites, and electronic intelligence. That means figure out in advance if there will be an hazardous activities and where. For example, that can be the case of a launch that can pose a threat to the allied constellation satellites. We are going to also dedicate particular effort in the study and evaluation of an innovative approach based on machine learning that can be very useful to identify anomalous situations automatically and to support the operators in their daily activities and decision as well. Passing to the next capability, that is support to military operation, we know that Space Command and Control needs to support military operation, and this can be done in all domain perspective, ground, sea, air, and space. And to do this, we are going to optimize the information exchange inside and outside the S2 system. So it means that the proposed S2 has to be linked with national C2 in all domain in order to exchange data and improve its own capabilities. We are also going to predict coverage on spaceborne assets over a given area of interest. I will show a next slide to better understand this concept. And this for us is a first aspect to be accounted for. This prediction can include the weather and space weather information as well. We are also going to dedicate to the cover prediction of our non-friendly assets, and this will be linked with anomaly detection that I explained before, and the maneuver detection that will be explained in the next slides. This, in particular, maneuver detection is useful to analyze how orbital maneuvers are related to the coverage needs. For example, in terms of revisit time. Concerning machine learning approach, this can be useful to also minimize the need of human intervention. So when the user is overloaded with large data volumes and complex scenario, machine learning can support the user by automatically provide suggestions and data synthesis to the user. And also to this, the deep reinforcement learning technique can offer promising perspective. One idea is to choose actions that minimize the reward the system receives over a period of time. It means that we will fix a period of time that can be, for example, the mission time, the time of the mission, and we will leave the agent explore the environment in order to learn, autonomously learn which are the best actions to choose in order to optimize the mission. Of course, by basing on the reward and punishment function. Okay, this is the example, a practical example that can show, can give an idea of how the algorithm can work. In this case, the user selects the area of interest that can be the mission area, for example, by designing it through the mouse on a map. Then the user selects a time interval that will be the mission interval and the allied sensors, and the algorithm computes which allied sensors are the most suitable to detect the satellite's passage over the area, which allied satellites overfly the area, and how to select the time interval to maximize the coverage of allied satellites over the area. This can be done with reinforcement learning techniques, as well as how to maneuver the allied satellites to maximize the coverage of that area. Concerning non-friendly assets, which non-friendly satellites overfly the area, and in this case, how to select the time interval to minimize the coverage of these satellites over the area. So in this case, it's a minimization target instead of maximization. If space weather data are available, we are going to use this to select the time interval to minimize the negative effect on space weather over satellite communication, because it's known that space weather activity can go in the direction of disrupt satellite communication. So before to plan the mission or during the mission planning, it's important to understand to predict the space weather activity because it's very related to the satellite communication performance.
Okay, good morning to everybody. The next capability that we are going to present is the maneuver analysis, which aim to extend the capacity to identify sudden changes in space object dynamics. It is composed of 3 macro steps that are the detection, aiming to determine the time instant in which the maneuver has taken place, the classification, aiming to discover what kind of maneuver the target has performed, and the anomaly detection to identify patterns in the target maneuver's history by statically analyzing significant parameters or measurement in time and extracting frequencies and occurrence. The maneuver detection is based on the consideration of 2 kinds of data sources that are the time series from orbit data files and the uncorrelated measurement from ground stations. Based on the data source, different methods can be used to extract information and to highlight features associated to the event. In the case of orbital data files, 2 methods are can be used, and they are the root mean square error or the time derivative. In the case of an uncorrelated measurement from ground station, it is possible to integrate this kind of measurement by means of different versions of the Kalman filter with by adding a control term to the system dynamics that activates only when a maneuver is detected. Once data are available and processed, they can be deeper exploited and this can allow the classification and the anomaly detection. In the classification phase, we divide into also here into kind of available data sources. If orbital parameters time series are available, it is possible to fit a Gaussian curve and execute the analysis of the peak. The standard deviation of the Gaussian curve is associated to the duration of the maneuvering action, and this allows to identify between an impulsive or a near impulsive maneuver. Once the entire set of orbital parameters is available, it is possible to build some pattern for non-maneuvers of the same type elevation. And at this step, apply machine learning algorithms to associate variation patterns in space object orbital elements to different maneuver classes and to obtain for each one of them, the associated probability distribution. Each classified maneuver can then use to define a pattern that an observed space object is following. To extract information, it is possible or to extract frequency component from this time series, or to design a recurrent neural network fed with historical data of the target, capable of predicting the trends of orbital parameters and related events based on long and short-term changes in input features. In any case, every event that does not comply with the expected pattern shall be reported as anomalous and further analyzed. The next capability that we describe is the satellite operative status assessment that is based on the processing sensor data and combining different sources of information, even within a multi-temporal perspective. It uses sensing sources, meaning the optical and the radar sensor, and it is focused on the light curve analysis for tumbling satellite recognition, and more in general on the analysis of the high resolution ground-based or space-based observation. It is an important capability because it is also an important interface for other capabilities such as the maneuver analysis, the drift assessment, and the pattern of life recognition. In any case, the capability provides a huge contribution in the space object characterization. It is based on sensing data analysis, and this kind of analysis can be supported by the estimation techniques such as the multiple model adaptive estimation. It integrates different measurements such as the radar-based one, and it employs innovative algorithms and approach related to the machine learning, mainly the convolutional neural networks, and it is based on the data fusion since it has to exploit data coming from different sources. In conclusion, we can remind that even though a gap in the European SSA exists and has been identified, it is possible to overpass this gap by means of a dedicated advanced solution that is the command and control system. That is the solution capable to provide European SSA capability. It is based on innovative approach and technologies, and it provides a lot of capabilities. We were reported, as Giulio said, only a set of them. And an important aspect of this system is that it provides significant opportunities for research and innovation in terms of artificial intelligence and machine learning approach, enhanced sensing information, data fusion and contextualization, and the whole domain perspective. Thank you.
Okay, so we try to be as fast as possible. Of course, we are at your disposal for any kind of clarification you need. In conclusion, just to stress 2 points that for us are very important. First of all is the cooperation with the Ministry of Defense in order to develop a capabilities that goes in the direction identified by our MOD, and also the cooperation with the universities for us is very important because we can bring on the industry, the innovative approach that are identified by the university, and the last point is for the cooperation at European level with other partners. These are 3 very important elements that are at the basis of our approach.
Okay, thank you very much for your presentation. We have one question from Marco Mattei. The question is, what kind radar sensor are you considering to use for detection and tracking of small size debris targets?
Okay, we can answer as Vitrociset for our view. We have identified the technology based on multi-static radars. That means transmitter unit and the receiver unit geographically located in different regions. We had some experience in this with the Virales radar, which is one of the assets used in the USST framework, and in the DIDP and the DF. In the other call that was introduced by Lieutenant Colonel Ferdinando Dolce, the call on sensor, our idea is to start from this knowledge to develop new multi-static radar. Performance and tracked on the existing radar tell us that this technology is suitable for surveillance purposes and tracking of small objects.
Okay, thank you.
Thank you.
If we don't have a further question, we can go for Eduardo Di Francesco. Last but not the least, of course, a methodology to manage the risk of obsolescence of a complex system. This is an update of a already previous shown briefing. So Eduardo, thank you. The floor is yours. Thank you.
Okay. Good morning to everybody. Thanks to Professor Da Fonte for the opportunity. I'll try to share the screen. Okay. It's okay? The screen is online?
Yes, now it is.
Okay. So I will speak about the obsolescence. Obsolescence, yeah, so many pictures on the screen. I don't know if you see the slides. See many objects. Okay. Risk obsolescence of complex systems. This is a paper already presented 2 years ago at Turing Congress, and now we have some evolution of this topic. Let's start from, okay, which is Cetel. Cetel is a company operating in integrated logistics support since 1973. In 48 years, we developed analysis and ILS for more than 120 complex systems. And let's go to the topic. The main focus of the integrated logistics support is to phase the degradation system. Now I put the phase the degradation and obsolescence, because in the terms obsolescence is daily by daily, year by year, becoming more complex and more important. The huge amount of technology, the urgency of technology has increased the criticality of obsolescence. So obsolescence is one of our new target. So let's try to define the obsolescence in a very little different way. Okay, obsolescence. Obsolescence is not a failure, but causes a functional failure. Influence the availability of the system to the chain maintainability and absence of spare, no responsibility of the spare. So you are not more able in time to recover the maintainability, and consequently we have no availability of the system. And this is standard. Okay, this is the end story. But now this becomes more and more urgent because software. Now the software in the complex system, specifically when you speak about dual use, we have we go to a little deeper in the dual use system at the end of this presentation. The software is becoming the critical point. Everyone has the experience on our mobile, how fast change the availability of your mobile and the function you have on your mobile. Because the software today replaced the previous vision, not always informing the user about this function. The obsolescence in this case sometimes is often desired because commercially, sometimes you will let the system become obsolescent to solve existing bugs, or you replace the software to resolve bugs. So actually, there is a very complex situation between the traditional hardware obsolescence and the software obsolescence. The mix is a very chaotic area. So the problem to solve the obsolescence is something very urgent. To solve this problem, we have used techniques related to the S3000L. Why this? Because we operate in the ILS domain, in the ILS scenario, and the ASD series, the new aerospace and defense regulation for integrated logistics support. Now today it's integrated product support, and S3000 is the center of this scenario of new regulations. And you can see on the screen, obsolescence analysis and software support analysis are two of the most important themes of the actual scenario. Let's go to the new approach, trying to not to suffer the obsolescence, but to lead the process of obsolescence. In which way? Try to measure the obsolescence. Sorry, change it. Try to measure the obsolescence and try to make contractually parameters to standardize the obsolescence key performance indicators. So the topic is to trying to make the obsolescence a parameter of the contract. Which way you can find, no? So we focus on contractually managing the challenge, trying to drive it from the contractual phase through the whole life cycle, and trying to be neutral, because actually the obsolescence is declared by the contractor, by the supplier. So there is no an intermediate neutral method to define the obsolescence. And this method should be integrated with the existing platform of standards. So shortly, let's go to the method we suggest. A complex system is made by functions. Functions are made by technology. Technology, every technology has its own curve, obsolescence curve. Let me get an example to clarify the concept. Your mobile, few years ago it was 2G, now it's 3G, and now it's 4G, and tomorrow is 5G. How long your mobile is able to do its job? Which is the period allowed for plan an obsolescence of technology of your mobile. And this is an example. But this example made about technologies. Now the complex six are made by functions, which are made by technology, and every technology has its own curve of obsolescence. Putting everything together and putting the concept together with the criticality of function. So you have to focus on the functions which are critical. You can mix the criticality of function together with the function obsolescence, summing the technology which made every function. And finally, mixing together everything and looking to only the function which you are using in the mission. You can define the criticality of the mission depending on obsolescence. Driving this process allows you to design the system looking for a future obsolescence and not to suffer the obsolescence which arrive on the already delivered system. A little more in detail. this is the same age, but now we have the parts and the reference on 1388 S3000L, because what becomes obsolescent is the part. Part means hardware or software, no matter. Every part is made by technology, and every technology has its sound curve. So all those items, relation between mission, function, parts, it's already present in the database, logistic database, like 1388 or like 3000L. So everything is there. Everything is mapped during the development of the system. Everything is mapped and already designed in terms of specification for what concerns the integrated logistics support area. So again, back to 3000, back to the software, back to obsolescence analysis, where we have some experience. We propose a lot of paper on this topic. And this is the solution we provide shortly. This topic is more complex, but as you can see, actually what you do, you have a complex system. You have the functional elements, you have the parts component in the functional element. Then you get from supplier the obsolescence data, and so you have the obsolescence. The modification of the process is you go to the function, go to the parts. Every part is composed by technological elements. Every element, every sound curve, and this curve can be designed neutral, not defined by the supplier or the prime contractor, but something that is part of a general concept of as a panel. You can make a panel deciding which is probably the 2G, 3G, 4G, 5G curve of obsolescence. So you can have a neutral observer that will define the curve, not defined by the supplier itself. And this makes the system more manageable in terms of contract. And finally, the result of those elements comes back to the obsolescence in time through another flow. Well, we developed the new model in 3000, but this is for if someone will enter in details, I'm available in a separate to speak about. And so concluding, because it's time to, and the last, so it's time to eat. So we propose a new KPI, a new key performance indicator to maintain the life cycle of the system, adding the obsolescence curve managed in a neutral way. And we verified that the standard SD3000L is suitable for the management of obsolescence in the new method. And we develop a model to do that. But the title of the presentation is the dual use methodology. So why dual use? Now, what's funny is that this technology has been mainly generated for a totally different sector, which is the smart city. In smart city, we are absolutely the same. It's a very complex system, the smart city, where the problem of obsolescence it's something which is very, very interesting, I would say. The integrating in so many technologies very, very similar to the technology, the method we use for a military complex system. And we develop for this type of sector an application which is basically our LISA for smart city beta, where we are going to examine parameters like mobility, governance of the system, traffic management, parking, geofencing, which the topic is absolutely the same. It is applicable in a dual use methodology, either to civilian and military system. So thanks. Shortly.
Okay, thank you. No, we appreciate the shortly because, as you say, it's time to end. So thank you, Eduardo. With your ST1000L, you recalled to my mind the AECMA 2000M.
Yeah, exactly.
I was a part of it. I was in the IT expert team, so I was part of one of the builders of this directive. Okay.
This is a proposal to enhance some parts of the AST specification with this the specific topic.
Okay. Okay. Thank you. So it's time to conclude. I would like to. So we have seen a wide picture of the space environment. What I noticed from the speakers that really is becoming with the characteristics of another further battlefield with all the concepts that come from sea, air, and ground. So I would like to thank also on behalf of President Cosenza, who is not for him it's not been possible to stay until now. Okay. So I would like to thank all the speakers, all participants. I don't want to abuse of their patience anymore. So my wish is to have next year in Pisa in presence the next conference. Pasquale, do you want to add anything?
Thank you for sharing this session with the usual professionality. It was very interesting from academic point of view to know that there are a lot of research possibility in the cooperation industry and with the Navy or our defense system in general. I attended very great attention to this new possibility offered by European Defense Agency. I know that there are not many universities. It's only some big industry and small and medium enterprise. It could be interesting to open this cooperation to universities that work in this field.
Well, you know that AFCEA is working as a bridge. So, I mean, the occasion is good to open a new relationship between universities and MODs. And also the wish is with the Polish Academy for next year to have some exchange of people, of course. So, thank you very much indeed again. And that concludes the conference for this year. See you next year. Thank you. Bye.
Okay. Bye-bye.
Thank you, everybody. Bye-bye.
Bye.
Thank you. Bye-bye.
Thank you. Bye.
Thank you. Bye-bye.